Hey everyone, thanks for coming. As you probably and hopefully know, this is an AMA with Arthur Conmy, who's a leading researcher at Google DeepMind exploring how to make black box AI systems interpretable. Notably, he's helped create Gemascope, an open source project with sparse autoencoders, allowing everyone to be a neurosurgeon for LLMs, so to speak. Hi Arthur, can you give us a quick introduction about who you are and maybe some of the recent projects you've been working on?
Sure, I can certainly do that, Kevin. Yeah, hello, I'm Arthur Conmy. I'm currently a research engineer at Google DeepMind, the AI company that builds like frontier AI systems like Gemini. But I work on trying to like understand how these systems work on the inside, which is part of a broader field called Mechanistic Interpretability, which is a many-syllabled phrase, but you can think of this as basically neuroscience for AIs and in particular LLMs. So we try to like figure out what the AIs are doing in terms of their internal parts, rather than just looking at inputs and outputs, which is a great way to look at AI systems, but it's far from the only way to look at AI systems. But I'm sure we'll get into that in due time. In the past, I worked at a startup in the Bay Area, actually, called Redwood Research, where I did some work there. Yeah, that's kind of like where I came from. And currently, I work in London in the DeepMind office and do lots of research with both folks inside DeepMind and collaborate externally. But thanks, Kevin.
Thanks so much for the introduction. I guess before we go on with the rest of the AMA, me and Rohan are gonna like introduce ourselves. So really briefly, I'm Kevin. I'm one of your co-hosts today. I'm a junior from the Bay Area at Bellarmine College Prep. I joined Hack Club at the start of high school and have attended hackathons such as Assemble. I currently also run a Hack Club chapter at my school where we've hosted hackathons for a lot of different students in the Bay Area over the last 2 years. I'm also currently doing a little bit of work on AI diffusion at the Equiano Institute, focusing on multilingual capabilities. And I'm also super interested in reading a lot of really cool papers on interpretability like yours, and particularly some of the work being done on model diffing with crosscoders. And so, Rohan, do you want to introduce yourself too?
Yeah, thanks. So hi everyone, I'm Rohan, your other co-host. I live in Atlanta, Georgia. Recently, I participated in Hack Club's Juice Shanghai event, as well as running some beginner machine learning workshops, contributing to the AI safety guide by Nikki Case. And I also run a small YouTube channel explaining my favorite AI and interpretability papers. And I've also done some independent work in MechInterp, such as measuring the effect of sparse autoencoder steering on honesty and math benchmarks. I mean, I'm really excited for this AMA.
Cool. So before we dive into like some of the leading questions we'll start off with, I want to first like introduce the rules before we go on with this AMA. So there are just a few rules. The first one is before you ask a question, make sure you have your camera on. And if you don't have a camera like available, that's totally fine. And also if you don't have a microphone to ask a question, you can just type it in chat. And I'm sure Rohan or I would be more than happy to read it aloud for you. Second is if you have a question, raise your hand on Zoom, not like with your webcam, but on Zoom, and then we'll call on you when we're ready to hear your question. Before you ask your question, you should introduce your name, your age, where you're from, and then a little bit about yourself. And then you can hop into your question, but make sure to keep it short and sweet because we want everyone to have some opportunities to participate. So, with that to begin, let's start off with the first question. This is a question I really had because of a recent post about AI 2027. I guess Rohan might have a little more to say there, but I'm really interested in what your takes are about like timelines for when AGI might occur.
Mhm. Sure. So timelines to AGI is extremely hard question to answer because of like two parts of it. Like it's both hard to answer because AGI, what general intelligence is in like AI systems, is like not clear to any person. It differs between everyone. Though I am going to give an answer in the end, I promise. I'm not going to just reject the question. And the other reason why it's hard is like basically any question about the future, like when will this happen? Like when will like this stop happening? Will the world get better or worse? It's just extremely hard to like answer because the world is highly chaotic. So the AGI timeline question is a hard question to start with, but to give some answer there, we can talk about when we'd reach AGI in terms of when, like, in my opinion, the best definition for this would be when most human work is automated. So, like, most work that most humans do now that provides value in the economy is done by machines, effectively. I don't think we're that close right now, but I think the progress has been extremely fast in the AI world. So I'm not confident when it would happen, but I would say within the realm of 3 to 10 or 15 years. I think it's likely. Again, there's no certainties here, but we could have systems that kind of automate like huge parts of what human labor is. Uh, my reason for thinking that is I think that AI coding capabilities and like automating doing AI research itself has sped up a lot recently. I can remember when I learned to code and I just write code into like a text file, and that seems like kind of unbelievable now when there's like so many AIs that can assist with vast parts of doing AI research. And I think that like there's a big question of like both when that will kind of automate like all of kind of doing AI research, and there's also a question of how much that would improve or like speed up the automation of like the whole economy. But I think that's like the important question effectively, and I think that like I'm pretty uncertain, but I think when that happens, there'll be like large scale automation of a lot of work. So I'll say 3 to 15 years or something, but again, very uncertain. And make sure you ask many people because everyone will have a different answer to that one.
Yeah, totally. Makes a lot of sense. I guess, Rohan, I know you're really interested about how Arthur's work in interpretability might play into maybe how timelines are operating right now.
Yeah. My specific question is what role do you see MechInterp having on long-term AI control strategies?
Mm. Yeah. So, why would it help to understand how AI systems are going to work if they're going to have like a very large impacts in the world, such as by automating lots of jobs? I guess that's the question I'll kind of answer, and maybe to give a bit more context for folks involved. Uh, when I do work on AI interpretability, my hope is that my work will be helpful for some point before the AI is kind of like automate or AI systems in general are automating huge parts of kind of human labor effectively. Because like it seems pretty difficult to make sure your work is important once huge parts of work is automated and you probably can't have as much of an impact. And so with my work, I feel that we will broadly be able to detect when AI systems are doing like unintended things when we can kind of read it in their outputs. So for example, today, many like language models and chatbots you'll work with will display a long thinking trace about what they're thinking about before they answer problems. And this is a good strategy in both AIs and humans. It helps you answer more problems when you write like a long thinking trace or produce a long thinking trace before answering a problem. But that's something that's pretty easy to monitor. Like we can just read that and it will allow us to tell whether AIs are producing like the actions we want or the actions we don't want. Whereas I think eventually sufficiently like intelligent systems will like not necessarily need to like use just like the like language space where they produce clear like words and reasoning. They might do reasoning, for example, with just kind of like vectors in space effectively. So there's no reason why the like thoughts of like AI models would have to be in like the human language that it is today. And if that happened, we would need better tools to find out what the AIs are like thinking before they produce responses. So at a high level, I think that's not the only, but one of the key motivations that I have for doing kind of interpretability research to really understand those kind of representations when they're not just stated in language as they are today, if that makes sense.
Yeah, that was a good response. Yeah, thank you.
I guess one more thing to add on to maybe your response about like looking at the reasoning tracing traces of models. I stumbled across one of your papers about how like chain of thought might not always be faithful. Maybe do you want to get a little into the work done there?
Sure, yeah. So I think I've recently worked on more work which is uh, not just looking at like the insights of models, which is obviously a core of my like work, but also more broadly just looking at like the language models we have right now and the reasoning we have right now, and seeing how much when like neural networks say that they believe some fact or say that they think an answer is one answer or the other, whether that's like truly what like they believe in other circumstances, or whether they really mean that and rather than lying or something like that. And we have found cases, it doesn't happen all the time, but does happen sometimes, that models will produce kind of like reasoning to justify one answer, even when they kind of know in some sense that that answer is not true. And this is kind of problematic because it also relates to that problem I referenced earlier, that if AI reasoning just explains what it's doing and why it's doing that, so like the models will say, here's your like code to produce like your, I don't know, experiment that you want ran at this point in time, and here's exactly why I think that's the right experiment to run. If we can trust that kind of reasoning process, we can determine whether the like AI is doing things for like the correct reason versus they're just trying to like produce like responses that look nice rather than are the thing we want. But all of that will fail if the AI is just not telling the truth in that reasoning chain. And so probably the easiest example to explain from that work is a set of experiments we ran by just like querying language models. And what we found was that sometimes you can ask a model a question in two different ways round. So we'd ask it, for example, does aluminium have a higher atomic number than magnesium? And then we'd asked it, does magnesium have a higher atomic number than aluminium? And the models would do things like answer yes to both of those questions, which doesn't make sense because like you can't have one thing having an atomic number being higher than the other and then reversing it and the other way around also having a higher atomic number than the other. And that's like a problem with the model's capability, like it's not a good model. But even worse, we found that the model would produce just different reasoning traces in both like scenarios. It would do things like, in one case, compare like what the actual numbers of those two elements were. And the other, it would say things like, oh, elements further to the right on the atomic table have like higher atomic number, so it must be the other way around. And this is a good case where we found that the reasoning doesn't match up exactly with what the model's like true beliefs are, as you can see in different chains. And so, yeah, that's just an experiment that we could run by just talking to language models. There's lots of good APIs and like good like internet kind of like resources on talking to language models. And I think you can reveal a lot without even having to look inside the models. But yeah, thanks for asking about the recent work.
Yeah, that's super cool. I just want to remind everyone that we're now going to open up the entire conversation to everyone. So if anyone has a question right now, feel free to raise your hand or put it in chat. And if you don't have a question, that's totally fine. But if you ever come to like the point in which you want to ask something or get more clarification, just always remember you could just raise your hand anytime. Cool. I guess we'll just move down the list of questions we had for you prepared.
I actually saw
Oh,
a question in the chat. Someone DM'd me. This is
cool.
from Bruce. He asks, given your experience and background in MechInterp, what fundamental skills do you think are most important today for high schoolers or undergrads to develop?
Yeah, that's a good question. So what are the kind of skills which I think are important for both like ML research and for like mechanistic interpretability research? I'd say there's like two broad like skill groups to work on. So like I'm a research engineer, but I think almost all folks who work in AI need to have some like good grasp of kind of research skills and engineering skills. And it's like probably like a dangerous idea to just have skills in one of those areas effectively. Or like it's possible you can be really strong on one of those ideas, but most AI researchers gain more by knowing some about research and some about engineering as well. And so what does that mean? What does research and engineering mean? So by research skills, I mean like kind of formulating hypotheses and then testing them to see if they're true or not, and having a good kind of sense about what the next hypothesis to test should be. So this is kind of exactly like the scientific method of just like doing kind of the experiments to figure out what's true or not. But a particular kind of skill to develop here is practicing figuring out the correct next experiment to do. Because there are so many possible experiments you could run, and no one has the time to run all of them. So the skill in research is to like find the shortest path through the kind of like space of kind of questions to ask. And it's a really hard skill. No one's good at it because it, as going back to something I mentioned earlier, involves kind of predicting the future to find the best experiments to run. But the better you get at it, the like faster you can do work, and that's really powerful in research. And then engineering, I think that like AI and interpretability in particular is very much kind of like a field where it's not very kind of like laborious to carry out experiments. So in neuroscience or in kind of like medicine, your experiments rely on kind of like organisms and like real like life work in wet labs and things. And this takes days of time and can often go wrong and needs to be restarted. But in machine learning, we just have everything in our computers and we just run it at like thousands of times of like parallel width with like thousands of experiments running at once. And so having the ability to kind of like both run those experiments and like know how to efficiently kind of like work through the hypotheses you generated is like highly valuable as well, beyond just kind of like picking the right like questions to ask. So I think both of these skills are highly learnable. You can just jump into doing projects to find out how to like kind of like go through research better, and you can just try and like grab a machine learning project, figure out like how to like train a neural network, and like by like figuring out when it's bugged and when it like doesn't train, and then maybe talking to a language model about what's going wrong, you can also learn kind of the engineering skills. But a great question.
Yeah, that was a great question. Thanks for the response. Josias, do you want to go next?
Yep, sure. Hey, Arthur, I'm Josias. I'm currently a gap year at Hack Club. I'm on the engineering team. I still don't have as much experience as Kevin and Juan has in AI, but I've done a bit of machine learning projects. And one thing that I'm really interested in is in mechanistic interpretability. What I'm curious about is how does mechanistic interpretability help us in like AI alignment? Like, so
Mm,
essentially, how does alignment itself look like? Does it look like essentially discovering secrets and maybe modifying the secrets or maybe deactivating
mm,
them to like prevent certain behaviors in these models? Or does it look a lot more like something closer to like fine-tuning these models?
mm. Yeah, so you bring up two possible ways we could use kind of like interpretability for AI alignment. So yeah, to restate the question, if I understand correctly, you mentioned that you were interested in mechanistic interpretability in machine learning in general, but you were wondering how like mechanistic interpretability connects to like AI alignment. So like ensuring that like kind of AI systems follow our like intended behavior, even when like it's kind of quite hard for us to fully specify what behavior we'd want from our like AI systems. Would you agree with the question, or would you like to rephrase it?
Yeah, I think you got it.
Cool. Yeah, sounds great. Because you mentioned kind of like things we could do, like detecting, you call it like secrets or like hidden behaviors of models that like we like weren't aware of them being present. And then we could either do something like flag that as like a model that we like wouldn't want to like deploy or use further, or we could do something like we could train the model further to remove that like kind of like behavior that we wouldn't want. And yeah, I think that like um both strategies of like detecting behavior, and then like stopping like using that AI model, like developing a new AI model instead, or kind of like further training of that model are like both pretty like great techniques if we could get them to work at all effectively. Like I think that's why it's like pretty like important to do work that measures like how well you're detecting some behavior. And a lot of kind of work with interpretability looks at like, can you detect whether there's a concept in the model or not? And I think that's important, so we can do this like catching models that have like concepts or like kind of like behaviors that we weren't aware of. Though I think it's usually a question of when AI companies are developing AI models, they rarely like want to just like fully like put that model aside and just like never touch it again, because like developing AIs is extremely expensive these days. So it's kind of like a state of affairs where to get like the most like safe models, the best strategy would be to just like not use the model when we like know facts that it's like misaligned effectively. But like because of kind of like the political situation, and it's a kind of competitive racing's kind of like world we live in, like probably it's a compromise solution to train that behavior to like be like removed effectively, and then like reevaluate whether the behavior has gone away. And this isn't obviously as secure as kind of like developing a new model, but I think that like if we had if we have better kind of methods of detecting bad behaviors in models, that's totally like a thing that like we should want to do rather than just like not fixing the problem, if that makes sense.
Right. It makes me wonder, are there machine learning architectures that are like easier to mechanistically interpret, maybe by design or maybe because of their nature?
Yeah, that's a good question. So most of the AI field, you might know, uses like the transformer architecture, which is like a type of neural network, like unlike like a CNN for images, but is like architecture generally for text, but it can be extended to other domains as well. And the transformer has like some kind of like pretty interpretable parts to it, and then some less interpretable parts, effectively, where it's quite interpretable because it has these things called attention heads, and an attention head like pays attention at a high level to every single previous like word effectively that's been said earlier in the prompt. And that's quite like a human-like operation. Like when I read sentences and then try and understand them, I'll often look back and see like what the important words in that sentence were. So that's pretty like human-like, and we can broadly understand that operation. But like there are other parts of transformers that involve just kind of like large matrix multiplications, effectively, like which is like the so-called like MLP, to use the word if you want to search it up later in a transformer, and that's like broadly speaking not too interpretable. And so yeah, I think that like a lot of kind of like mechanistic interpretability techniques in some way or another look like replacing the like not so interpretable parts of our like neural networks with more interpretable parts. And so, for example, a sparse autoencoder, which is a popular tool, which is you can search up, is also has an acronym that's an SAE. That's a tool which kind of like can be used as a replacement to some uninterpretable parts of a language model. And I will actually drop a link in the chat to a demo we have of using sparse autoencoders, because it is very cool if you have some spare time or want to flick onto it while you're on the meeting, to see what the like insides of models are like really like with these sparse autoencoder tools. So I would say most interpretability techniques actually look like trying to make the architecture more interpretable, but there's various ways to achieve that. And yeah, I think that it's a good research direction.
Cool. Sahidi, do you want to ask your question next?
You think you're muted?
Yeah. Yes, of course. Hi, my name is Sahidi. I am currently a senior in Atlanta, Georgia, and I just had a question that I guess is more about your work. Though I find your research in AI interpretability very fascinating, I'm kind of curious about how like ethics plays a role in your research, and specifically like what ethical values do you hold true to yourself in both your personal and professional life, especially as you do this work?
Mm, mm. Yeah, it's a great question. I think that like AI development is like a research area where it's like particularly important to like be like conscious of the ethical implications of work, because like AI systems almost always are like used by like a vast number of people in their deployment. So in my work, I've tried to always ensure that like I'm doing work in a research area that I think is broadly having like positive impacts on the world, effectively, where I think that like I have mostly worked on like AI interpretability, but like I think it's possible I could work on like pretty different projects at like Google, for example. And I think that AI interpretability and the mission of trying to like better understand like how our like neural networks work is broadly like a positive impact research area. But like I don't think that's true for like every single research area in terms of using like AI systems. So that like I think it's like important to like think like carefully about like what the kind of like effects of like different research areas are. And so I think that's like I think one of the key values I would hold. And I think there's also like a kind of different point about kind of like the integrity of like scientific research, where like I think that it's like often it feels tempting when you reach like a moment of frustration to kind of like represent kind of like AI research and what your results are as kind of like much more exciting than they really are. It's like kind of hype, effectively, but it's really like as a sad fact, something that plagues like almost all AI research, that like there's always this temptation to make research look better than it really is or whatever. And so I would hope to think that like most of the research I've done like accurately reflects where like the results really show effectively, rather than misrepresents kind of what they show. So it's maybe a different form of ethics, but I think integrity of like the results that you report or whatever is like another kind of fact that I think is like quite important to keep in mind in AI research.
Thank you.
Thanks for the question, Zahidi. Hambo, do you want to go next with your question?
Hi, my name is Humbo. I'm a underclassman at Kevin's. I'm a sophomore at Bellarmine College Prep. And so my question here today is, based on your research today, do you think there could ever be a possibility of a generalized MechInterp model where it could be able to, like figure out the neural networks and the pathings of all types of AI models as opposed to like specified ones?
Mm, mm. So just so I understand correctly, are you saying, is it possible to create like one like tool that can like
Yeah,
understand all models at once, or like one methodology which like if carried out would understand all models at once?
I think
If that
like I think my question would be probably something like one, like yeah, like what you said, like one tool or like one generalized method that will be used to
mm,
hopefully
mm,
like trace all like how all AI models are thinking.
mm. Yeah. So I think there are like versions of this that like could work effectively, but I think I would be pessimistic about the version that is like one tool, like I don't know, one like particular like neural network or something that was like useful at interpreting kind of all neural networks. I think that would be because uh, it seems to me that the number of functions that a neural network can implement, like the number of different ways its kind of weight can be configured, is just like very, very large, because like these models have like billions or possibly even trillions sometimes of parameters. And so to be able to understand many, many, many different kind of sets of trillions of parameters, all with one tool, that would be surprising to me overall. Though having said that, I think that like it seems possible, but like it's going to be tough to like describe one methodology that would work for like a large number of neural networks and like work to understand them. uh I think one reason why I think that this is like easier than like having a single tool is we might think that uh yeah, like the course of AI development might like continually like kind of rely on models being trained on like all of the internet. It's like the current approach, or like large fractions of the internet. And if that happens, then there'll be some like strong similarities between all models, if you see what I mean. So we might be able to say, like with our tool, if we also train our tool on all of the internet as well, we develop a methodology where it's trained on all the internet and then looks at each model, or is trained with each model or whatever, then that tool might work with each model. So that's my sense overall, that if models are broadly trained in a similar way, then maybe, but like I'd be surprised if we can just get lucky with one tool, like as just like a fixed neural network that understands all neural networks. Does that make sense?
Yeah, that makes sense. Thank you.
Cool, no problem. Good question.
Thanks, Hambo. Shrey, do you want to go next?
Oh yeah, so I'm Shri. I'm in seventh grade. I'm from California. So, what do you think is the balance? Should be the balance between open source and closed source models? Like both of them
Hmm.
have advantages and disadvantages.
That's a great question. So, to be clear, I don't make the like call the shots on like what Google does that's open source and doesn't. Though I was like very like thankful to everyone at Google who allowed us to open source like hundreds of sparse autoencoders, as I put in the link in chat. So that's what I've interacted with in terms of open source. But as an answer to your question of like how should we balance open source and closed source, I think first of all it's like extremely important that there are like good kind of neural networks and good close to frontier AI models that are open sourced, for the reason that like having kind of open science and reproducible science that's done by academia and large kind of fractions of the world who aren't working in large AI labs is like so important for like both understanding the models and having better safety of the models and finding new techniques and kind of verifying claims that are like whether they're true or not or whatever. So I would think it's extremely important to have some close to frontier models. I think that like there's also like risks when companies kind of like deploy new models and they're open source and they say things like, well, this is like a frontier model, it's state of the art, it'll be better than any model we've ever seen before, and it's open for everyone to use. I think that's a bit dangerous. The reason being that like if it really is true that it's like better than all of the prior models, it will have new capabilities that we're not even aware of yet, and it will just be given to all people to use or whatever. And you can't kind of press Control Z and just take it back once you've given it to like everyone on the internet. And so I think that like the best strategy of like AI open sourcing would be like open sourcing slightly off the kind of frontier models when we're like pretty sure that these models aren't like highly dangerous effectively, or that we've built better defenses with our like more powerful AIs or whatever, and then we open source them then, if that makes sense. Because I think that like the fact you can't take back open sourcing seems like it's dangerous to therefore open source like when the best models as soon as they come out. But as I say, not my job to call the shots, but that's my opinion there. I think it's so important to have open source models.
Okay, thank
Certainly
you.
super interesting. Thank you for the question. Madhav, would you like to go next?
Yeah. Hi, Arthur. I'm Madhav. I'm a Swedish side. Senior from India. And now, in this gathering here, most of the folks, they're particularly interested in AI. But if we, let's say, take a mean across the average population, mean across the population, we're going to see a slightly lower interest. So, given that people influence policy, how and what would you want people who are, quote, not as interested in AI to know about AI? Because it's an important and emerging technology. So yeah, would you want them to, maybe engage with like the Blue Dot course or something, or go to public talks? What kind of a thing do you want to see?
Yeah, that's a good question. What do I think is important to know about AI if you're not like kind of like being fully in AI and like understanding all the kind of nuts and bolts of what's happening? I think that it helps. Yeah, here's what I think about this. I think it helps to have a good sense of like the trends in AI and the key kind of like the key variables that are like inputs and outputs of AIs. So that's pretty abstract. What do I mean by that? I mean that like there are some factors which are like extremely important to how like good AI models are. So two of those would be like how much data the model is trained on effectively, and also how much compute like was used to train the model. So how many computers we used to train the model, and in fact times by how long they were like turned on for effectively. And there's some like pretty great kind of graphs online that like obviously have more detail when you dig into them, but I think it's Epoch AI, should be epoch.ai. Yeah, epoch.ai shows some great kind of trend lines of how much compute is used for models and like how much data has been used for models. And those are like inputs to AI, like we put those in before we train our models. And then you should also look at the kind of like outputs of models. So like how good is it doing on like the hardest math tests in the world, or on like hard kind of visual reasoning tasks, because the models are like much worse than humans at visual reasoning tasks at the moment. And so I think that like, why is it important to look at those trend lines? Well, it gives you a sense of where AI is like getting like a lot better over recent years, whatever, and we should expect like big improvements, and areas where progress has been like somewhat slower, effectively, and it would be surprising if AI gets like way better in those domains. And so having a sense of like the inputs and outputs to AI and trend lines seems pretty important and doesn't require too much like deep understanding. Does that make sense as an answer?
It does. Thank you.
Cool. Thanks for the question.
Yeah, and I was like looking at the news, and I remember seeing like our education secretary calling AI like A1. So yeah, like educating people about how AI is progressing and how data is being used is a really interesting question. Thank you so much. Michael, would you like to go next?
Yeah. Hello, I'm Michael. a 14-year-old from Czech Republic. It's currently 3 a.m. for me. And I'd like to ask if, when you adjust a model with more training, can you kind of like predict what it will output? For example, it has a bad output when someone asks it for a joke, and you retrain it to try and fix it. How do you like see if you successfully?
Cool. If I understand correctly, what the question was, it was how do you kind of like tell whether the AI is going to produce like a bad output? And you gave the example of like if you ask it like to produce you a joke, how would you tell like in advance whether that's like going to be like a helpful joke versus not? Would that be a good summary of the question, or do you want to like clarify something in it?
Yeah, related to the like retraining you said. If the model is bad, you don't just throw it away, but you retrain it.
Got it. So is it a question of like how do we like find the kind of cases where the model is bad so that we can retrain it, if I understand correctly?
Yeah, basically.
Cool. Yeah. So I think that like there's like I guess two like kind of like classes of approach you can use to like try to find how like AI is like producing like bad outputs effectively. So there's basically kind of like the black box approach, which means like we don't use the internals of the model. We treat the model as like a black box. Or the kind of interpretability style methods where we look on to the inside of the model and try and like use like facts about the kind of like insides of the model. And those are kind of the two approaches we can use to like figure out what like how AI is behaving. So to briefly sketch two ideas there. So for like black box approaches, we could just like ask another different language model to read all of the kind of like outputs of the model effectively. So maybe 1 or 10 outputs per different questions you ask the model, and then like highlight them as like good or bad or very bad. And it sounds so simple, but it really just does work a lot of the time. And you can just look at all the cases which are like labeled as very bad, and that will kind of work. And then for kind of model like internals approaches, what I mean by that is the kind of interpretability type stuff. You could then do things like, for example, see what would happen if you like force the model to say something that was bad as an answer, and then look like how its internal activations looked, like in which directions in space its vectors pointed, and then see the cases where like it really was kind of pointing in the bad directions internally when producing answers. So yeah, that's a good question, and there's like two different styles of approaches to like use there to like find when cases when AIs are behaving in ways we don't intend.
Yeah, that's for your answer.
Cool. Thanks, Michael. Bruce, take it away.
So hi, I'm Bruce. I'm a senior from Champaign, Illinois. And I actually have two questions. I'm not sure, should I just ask one of them and then come back and ask the other one later? Kevin? Yeah, okay. So my first question is that it seems that AI, or in general, like a lot of these like learning models have to take advantage of these very, very high dimensional vector spaces in order to create complex representations of information that humans might not necessarily be able to extract information from. But with things like linear algebra, we are able to do so with like machine learning models. And my question is like, in general, what are some strategies that you use or best practices to use for like trying to understand like data when it is embedded in a very high dimensional vector space?
Yeah. So that's a great question that like you have these like AI systems like language models. You can play with it even in Google Colab if you like load them up in a few minutes, and you'll be able to like look at their internal states, but they will like generally be like hundreds of dimensions large, so 100 different like values, which like isn't very like interpretable as a human. Like it's even difficult to visualize 3D space very easily because it's kind of large and isn't fitting on a 2D computer screen, and there's like hundreds of dimensions. So what is there that like is like useful as a tool for like understanding these spaces? The best methods that we found, in my opinion, are the kind of like sparse autoencoder based approaches. So you can search up sparse autoencoder to have some reading there. But like the idea of the sparse autoencoder is that what if, despite lying in like a huge dimensional space, on each time you looked at what the vector was, there was only actually a few kind of concepts that were relevant there. So if we're talking like a language model or whatever, and you asked a joke, you might say, well, there's like a question mark, so there's a question. It's also humorous, whatever. It's also, I don't know if the joke's about like if it's a knock-knock joke, it's also like referencing someone knocking on a door. There's not that many things happening in any sentence, for example. And the idea of the sparse autoencoder is that if this was true, we should expect to see that like high dimensional vector be like the sum of like several different concepts, but just not that many concepts of them in total. So that's like the sparse part. The thing that you like trade off here effectively is that despite every single one sentence only involving a few concepts, like say it's a knock-knock joke, a question, knock-knock, someone's meeting someone else, it's humorous, there's only a few concepts there. But if we think about all possible things you could ask a language model or a chatbot, and all possible concepts that you can talk about in language, that's obviously way, way bigger, effectively. It's way bigger than even a few hundred. And so the idea of the sparse autoencoder is, what if all of those were different kind of like concepts that could be present, but at one given time, maybe only a few were present. And I think that like hypothesis that you can then like test by training neural networks to have a large number of concepts, but only a few of them active, is like a better way of visualizing and understanding what's happening than just looking at the high dimensional vector. So sorry, I just gave you an introduction to sparse autoencoders if you weren't hoping for that, but like that's my answer there, I guess, to like high dimensional space understanding.
That was a super interesting response. I'll definitely read up on that. Thank you.
Cool. And just before we get to your question, Kevin, we're gonna do like a 5-minute lightning round, and I'm just gonna ask like a bunch of questions that might not really be related to AI, but it's supposed to be a little bit more interesting, get us a little hyped. I guess I'm gonna start off with like this or that questions, if that's all good with you.
Say again, sorry, I didn't catch it.
Sorry, this or that questions.
This or that.
Yeah, like a one-word answer. Okay, coffee or tea?
Coffee.
Really? Okay. Tabs or spaces?
Tabs.
I see. And then like the tabs turn into spaces, or?
I think that's how like I like the auto formatting, but I like hitting the tab button. Sorry, I don't know if that's a bad answer. I like it to appear as
That's
spaces, but I like hitting the tab
that's the right answer. Yeah. Okay. Dogs or cats?
button. Dogs.
Cool. Me too. Mountains or beaches?
Mountains.
Really? All right. Let's see. Vim, Emacs, VS Code, Cursor, Windsurf, whatever editor.
Cursor's the best. I don't mind Vim though, but Cursor's the best.
Cool. And then light mode or dark mode?
Dark mode.
And then finally, pineapple or no pineapple on pizza?
No pineapple on pizza. No way.
Okay. And that's like the this or that questions I had planned, but there's like a few other ones. The first one is, if you could go back in time to talk with like anyone, who would it be?
Ooh, that's a tough question. Who do I think's a very interesting person through history? Probably someone from ancient Greece. I feel like the ancient Greeks were people who just like figured out tons in maths. Maybe this is biased. I did maths when I was in college a lot. But like, I don't know, like the school of Pythagoras or something, or like some of the Greek philosophers. It just feels like they were like way, way back in time and figured out so much stuff that seems like an important part of history to like be present at. Obviously, I need to speak the language. There'd be barriers, but like ancient Greek philosopher or mathematician, for example, Pythagoras.
Yeah, they seem pretty chill. What's your what's your favorite podcast or like audiobook nowadays that you listen maybe in the morning or the afternoon?
I really like a podcaster called Dwarkesh Patel. He does kind of like tech style interviews with like quite a lot of people across the kind of like tech world, and also like he had like some war historian like podcasts as well. So I'd recommend Dwarkesh podcast. He just like has like fantastic questions and like a very interesting podcast. Big recommendation.
I also second that. Very good podcast.
Cool. I'll check that out. And last question of the lightning round. I don't know if you know what like the Spud Bros are.
The what bros? I don't think I know them.
Sorry, the Spud Bros. They like get a potato, they like cut it in half, and then they put like beans on it, and then cheese, and then like tuna. It's
Okay.
like something I saw on like my For You page that a bunch of like British people had. So I was wondering if you had any thoughts, like good or bad. Have you had it before?
That's a decent British meal. Yeah, it's like we call it like jacket potato. It's like the British phrase for it, but it's like baked potato with like baked beans. It's like a simple, easy to make meal. It's good. It's good. I haven't heard the spread bros before, but it's good food.
Yeah, there's like supposedly like a feud going on between like the Spud guys or something and like the Spud Bros. So, I was wondering if you knew anything about that. Okay, let's get back to like the main programming. Kevin Thomas.
Hey, I'm Kevin. I'm a high school senior from Vancouver, Canada. We have a lot of mountains here. I think you would like it. My main question, well, I don't know too much about Mechinterp and like SAEs and stuff, but from what I've read, like the state of the art in SAEs is mostly like interpreting models and then like maybe making interventions in them and changing these things. And the main goal for like Mechinterp is safety. And I was wondering, do you think it's a possibility for, just the prevalence of like open source SAEs to make AI like more dangerous in the sense that like people can use these SAEs to like intervene on like large models with much less compute and make like the large models a lot worse. Like for example, how we're already distilling outputs on like large models with less compute. Would SAEs also like run the risk of making large models more dangerous with less compute?
Yeah, it's a really good question. Yeah, so I think there's like a lot of things you pointed out there that like are like not like are like different axes, and I've kind of maybe pretended somewhat that they're the same axis. She said something good there that was like most of kind of mechanistic interpretability is about AI safety, and I think that like you actually totally validly point out that like understanding how AIs work isn't really inherently to do with like safety of the models or like lack of safety of the models. It's kind of just like a different axis. It's like X and Y axes effectively. And I think that like there are reasons why a lot of people who are like interested in making AI safe have gravitated towards like interpreting models. Namely that like there's lots of ways to just kind of like make the models bigger and like more efficient and more capable that don't really involve any kind of understanding whatsoever. Like you don't need to understand these systems to make them better. And I mean, understand like a low level. Obviously, you have to like understand that it's a neural network and stuff, but you don't need to understand what it's learning on the inside. And so I think that like the field has broadly like not felt the need to like figure out what's going on inside the models, but for safety, when we could worry about the models having like hidden goals and things like that, I think it's pretty clear that we do actually need that internal understanding. So yeah, I totally agree that like there's like coincidences almost that have led to like more people in safety doing interpretability work, but they are ultimately different axes. I think for the same reason I mentioned earlier, that like the default path of progress for AI just doesn't really like go through understanding at the ground level how AI works. This means that I'm not too worried about like the negative impacts of my like work in interpretability overall, because I don't think it's like the primary thing that like people are trying to like achieve with like interpretability effectively. They'll have lots of other ways to make AIs more powerful or better or remove guardrails without really understanding what's going on at all. Having said that, there are cases where people have like removed guardrails more easily by using interpretability. That's happened before. And so I think it's important to be aware of. And I think that like if there were like extremely like powerful open source systems or whatever, then it would give me like more cause to like be like cautious about kind of research I was like publishing on those models. But I think in the current like regime, we are living in that world where the models that are open source are somewhat behind the kind of very best AI models. So I'm not too worried about doing my kind of like work on those kind of open models. Does that make sense?
Yeah, that makes sense. Thank you.
Yeah, totally. Thinking about how these things could be used against safety is honestly really important to think about too. Rohan, did you have something to say?
No, I was just gonna say, Jekyll Long, if you would want to ask your question.
I'm Jiko. I'm from the Philippines. I'm originally from the Philippines. So this is my general question. Since there's a lot of AI research booming here in the Philippines and they collect a lot of personal data from different people, in your opinion, would AI affect our privacy in extreme way?
Sorry, I didn't catch the last bit. You said there's lots of personal data collection. I'm not sure by who. I didn't catch the question bit at the end of that.
Okay, so they collect a lot of personal data from different people because of their AI research. Like, in your opinion, would AI affect our privacy in the extreme way?
Would AI affect privacy in the extreme way?
Because of like this research is blooming here in the Philippines.
Yeah, so I think there's like two different, like highly relevant forms of privacy for kind of the work I do and like the work that's done inside like big AGI companies, which is there's the privacy of like using like chatbots and using the kind of like interface to talk to AI systems and work with them, where you might ask a question, you might not want that request to be like visible to like the company who you're sending it to effectively, and so that's kind of like a privacy worry you have. Maybe you don't want it to be trained on in the future, for example. That's like the first part of privacy, and the second part is that most kind of information on the internet can be trained on effectively, and so information just out there on the internet could be trained on, for example, by AI companies. I think that like there's like pretty different kind of like considerations in both of those cases. So I think that like most AI companies have policies where they'll say, if you have this particular type of subscription or you talk to an AI in this form of chat, we will like delete your kind of like history and we won't like record that or whatever. So I think AI privacy is doing pretty well on the front of like having interfaces to models effectively, where like I believe I don't know the like exact terms off the top of my head, and there are so many AI companies these days that I don't know exactly. But if I recall correctly, like if you delete your chat in ChatGPT, I think, and I believe in other chatbots as well, then like the company says we will never store that message on our like in that interaction on our servers effectively after like some deletion time. Like they can't instantly remove it. So I'm like kind of optimistic that like there'll be good kind of policies for preventing kind of privacy breaches on the kind of like interface to AI side. And then I think the like internet question is like a bit tougher because just like it's pretty unclear what the kind of like status of training AIs on just like large sets of information across the internet or whatever, what the kind of like status is for that going forward effectively. And so I think that it's like important to be aware that like if you produce large amounts of information on the internet or whatever, then like future AI systems probably will know some facts about you when they ask or whatever. I think that like it's surprising to me that like my name doesn't appear too often on the internet, but every now and then I'll ask an AI model, and every time I ask them, they know a few more things about me just purely from just like the internet. And so that feels like an important thing to be aware of. That the more your name or like the stuff that you produce on the internet is there, the more like AIs will probably be able to talk about that in future.
Awesome. Arthur, I have a question for you. So this could kind of be like very broad question, but like recently I read your Google DeepMind's team like status update, like deprioritizing SIA research, and then right after like Anthropic released their circuit finding work, and it generally seems like the field of interpretability is moving towards like very compute heavy resource intensive work. So from that perspective, like what scope do you see for like possibly independent interpretability researchers on like low compute budget to make impact in the field?
Yeah. So for what it's worth, I would agree that like a lot of work that like AI labs try to do involves like large amounts of compute, because for the same reason that it like makes the eyes much better, we'd like overall like to do the work that can like benefit a lot from lots of compute. But having said that, I would say for what it's worth that both of like the updates that like we've made about like sparse autoencoders and the recent kind of research progress from Anthropic, I think that like a lot of this research is kind of like scoped out at like a small compute scale, effectively. Like while I wish it was true, I could just click a few buttons and just like run like tons of different machines at Google that would like cost like thousands of dollars to like use. It's actually not the case at all. There's always kind of like overheads and complexity when using like vast amounts of compute resources. And so even when like those are available, most researchers tend to work with smaller like scale experiments. And then when it works well, or when they want to test like a hypothesis more deeply, only then will they actually use kind of like the huge models and the huge amounts of resources. So when I see like papers written by like independent researchers or academia that use not like that much compute effectively, I like barely kind of react to it differently or whatever. I'm like, that's exactly the kind of thing that I would do if I was beginning an experiment effectively. And maybe I like will like have some worries that like at the biggest of scales and on the biggest of models, the conclusion will be different. It's the same process that I would use to get started with a project. So I think that like there is still like an awful lot that like can be done by like almost anyone effectively, because of the fact that like everyone does experiments at small scale first, if that makes sense.
Yeah, that actually was like a very illuminating answer for me. Thank you. Yeah. If does anyone else, I think Kevin, maybe you're raising your hand. Or actually, I think we should probably start counting down questions.
Yeah, I think maybe
Yeah.
for today, that's like the end of all the questions
Yeah.
we had. Because I know Arthur, it's like really, really late for you, and we want you to get like sleep, get ready for the weekend, have some fun. Don't want to hold you back. So, if anyone has like any more questions, maybe Arthur, you'd be open to them emailing over some questions if possible.
Yeah, that sounds fine. My email is just my personal email, my first name and second name at gmail.com. And so feel free to email that.
Cool.
Perfect. Well, thank you so much, Arthur, for your time, especially with the time zone and everything. But
Fine.
we really, really enjoyed this talk and wish you all the best and everything as well.
Yeah,
Have a
thanks so
great
much.
day.
Those are some great questions. Hope this was helpful, and hope you can get some machine learning and interpretability work done. So it's really
Yeah.
nice meeting. Yeah.